Hey there. Imagine this, a greenhouse that waters itself, adjusts the temperature, and runs entirely on solar energy. Sounds futuristic, right? Well, not anymore. Welcome to our final year project, the solar-powered self-regulating greenhouse ecosystem. It's not just smart, it's sustainable, scalable, and completely automated. This project was made possible under the guidance of our respected supervisor, Dr. Iqbal. And the team behind it? I'm Hamid Ali Khan, and my teammate is Malik Abdullah. Together we took on the challenge of combining automation with renewable energy to make modern farming easier and more efficient. Stay with us. We're about to take you inside the system that does it all, automatically. In today's world, agriculture faces new challenges, from climate change to water scarcity, to the rising cost of electricity. Traditional greenhouses require constant monitoring, manual watering, and heavy energy consumption. But what if we could change that? Our project introduces a solution that's automated, energy efficient, and eco-friendly. By using sensors, smart logic, and solar energy, this greenhouse takes care of itself. It waters plants only when needed, controls temperature and humidity automatically, and runs entirely on clean, renewable power. That means lower costs, less manual work, and healthier crops. All right, here's a look at the block diagram of our system. Let's start at the top. The entire setup is powered by a solar panel, which sends energy to a solar charge controller, specifically the ST-W1210 model. This controller charges a battery and regulates power flow to the rest of the system. From there, power is supplied to the ESP32 microcontroller, the brain of our project. The ESP32 receives input from two key sensors, the DHT22, which monitors temperature and humidity inside the greenhouse, and the capacitive moisture sensor, which checks the soil moisture level. Once the ESP32 reads this data, it decides whether the greenhouse needs action. For example, if the soil is too dry or the temperature is too low, the ESP32 sends a signal to a set of relays. These relays act as smart switches that control three components: a water motor for irrigation, a fan to control humidity, and a ceramic bulb that heats the air when it gets too cold. And now, here's our working prototype in action. This setup brings everything we've talked about into the real world. Right in the center, you can see the ESP32 microcontroller. It's the brain of the system, constantly reading data and sending commands based on our preset conditions. On one side, there's the capacitive soil moisture sensor inserted into the soil. When moisture drops below 40%, the water pump, placed inside the tank, is automatically activated. You can see the water flowing to irrigate the plants. Once the soil reaches above 80% moisture, the pump turns off, saving water. Right next to that is the DHT22 sensor, monitoring both temperature and humidity. If the temperature falls below 25 degrees Celsius, the system turns on the ceramic light bulb to gently warm the greenhouse. The setup is powered by solar energy using a 12-volt solar panel, a rechargeable battery, and the ST-W1210 charge controller, which protects and manages the power supply. Everything works automatically, based on live sensor feedback. And that is our solar-powered self-regulating greenhouse ecosystem, working exactly as we designed it.